So, do's and don'ts of dimensioning. We've created basic template. We are going to refine and evolve and take that drawing template and the sheet format, and as it goes through several iterations, it will get better and we'll be able to use it more. If we don't do anything else to it, that's fine too. We have something that's maybe a little more functional. The other side of it is if you want to use the SolidWorks default A landscape for any of the exercises and assignments, that gets you in straight into dimensioning. And again, these are optional if you have time, if you want to invest in the process. So the do's and don'ts of dimensioning are in I think I mentioned the 14 ASME Y14.24. Dimensioning, each of these is kind of a separate item with maybe a little bit more explanation. And again, these are suggestions. You have to put the eye on for your industry, for your company. Um, Most of these are common sense or should be common sense, and I certainly don't want to read all of them, but when we're setting up the dimensions, should be given clearly, can be interpreted in only one way. Uh, do not duplicate. There is one later on that says if you need to have a reference or dual dimension or a reference dimension, then you put parentheses around it. Dual dimensioning is both inch and metric for clarity. Dimensions should be given for points and surfaces for the functional relation. That kind of goes into the GD&T for our geometric tolerancing. Um, Surface finishes, center lines, and then one that I think is very important, I highlighted to it, dimensions should be given so that it will not be necessary for the machinist, me to calculate, scale, or assume any dimension. You do not want me doing math to make your parts. Dimension features should be attached to the view where the shape is best shown. A lot of times you just have to make those decisions. Dimensions should be placed in the views show the true shape. We will do a project where we will dimension an isometric view, but typically it's only to show maybe the outer envelope or give a sense of scale or something along those lines. But our three view drawing are going to be the preferences placed in views for the true shape. Dimensioning to hidden lines, we're going to be able to section, crop, do um, those breakouts to kind of avoid the hidden lines. There may be times where um, you go ahead and do it to get it moving, but you want to put in the extra effort to make a nice professional drawing. Clarity is promoted, long extension lines are avoided. Applying to two adjacent views, so dimensioning in the front view and stretching it all the way across the right view, yeah, probably not a good idea. And then place the dimensions, again for clarity, but should be placed, the longer dimensions should be placed out all intermediate. Sometimes the lines will cross, but try not to. All units, unit marks should be omitted. And in our process, one of the big things between the inch and metric is that the leading trailing zeros are kind of an indicator. Don't expect production personnel to assume that a feature is centered. The symmetry and the center line symbols have kind of gone away from the 2018 standards. So if we put in a center line, we're probably going to dimension to it. I think I mentioned that this was the technical drawing. This is the 15th edition. This do's and don'ts goes back as pretty much as far as I can remember. So before I get too far, well, I'm already too far into it, but I want to have these as the a reference when in doubt. And so let's see, let's go on to 14. A dimension should be attached to only one view. Detailed dimensions should line up in chain. Um, Complete chain of detailed dimensions should be avoided. You want the overall dimension and you want the stack up, and omitting one just means that you're, again, back to not doing math and providing clarity. Because chain dimensioning provides also for a stack up of tolerances, I would almost say don't chain dimension. Baseline or ordinate is going to be the preference. Dimension line should never be drawn through a dimension figure, spaced uniformly, no line used as a dimension line or coincident with a dimension line. Dimension line should never be joined end to end with any line on the drawing. You always want that little bit of a gap. Do not cross, should not cross. When extension lines cross, there should be a break. SOLIDWORKS provides for that, but I don't really worry about that. Usually that's in a diameter or a radius extending across one of the linear extension lines. Center line may be extended and used as an extension line, in which case it is still drawn like a center line. Center line should not extend from view to view. Leaders for notes should be straight, not curved. And curved is more of an architectural thing than a engineering thing. So keep that in mind. Slopes, and then let's jump over to the next page. More extensions, dimension figures, heights. 1/8 inch is about standard. Angles, and try not to do too many fractions. There are places where fractions, but I think the decimals, and again, it's architectural versus in engineering or mechanical. Cylinder is dimensioned by giving both its diameter and length in the rectangular view for holes, and then the manufacturing processes are generally determined by the tolerances rather than noted in the drawing. If you need a specific process or the process has been engineered into the part, then you want to give the processes in the order that they would be performed. Otherwise, it's up to the machinist. They know what tools they have. They know what processes they can perform to hold your tolerances. You do your job, you let them do their job. All right, so that's one of the reasons why, if you have the chance to do some training, get a chance to run a mill, a lathe, do some grinding, take it. It is very beneficial in your dimensioning and thought processes on designing parts as well as dimensioning parts to go through that process. And if you're a machinist, it helps to do some drafting so that you're thinking about what the other guys are doing. All right, drill sizes expressed in dimensions, because we talked about numbers, letters, decimals, metric. Try not to mix those up too much. Circles by its diameter, arc by its radius. That's kind of standard. More and better. Try not to do the not to scales. The modelers are going to be really good at keeping those in. We set the tables for those reasons. Mating dimensions, pattern dimensions. Again, try to avoid the fractions unless it is something that you're going to measure with a tape measure or a rule. There it is. Decimal dimensions should be used for all machining, and cumulative tolerances where they affect fit. So stack up of tolerances, And then that jumped out of it. All right, so I tried not to read all of those, but there are a lot of important items in there. Oh, and probably did not want it to do, oh, definitely did not want it to do that. So my Windows 11 kind of changed my scale there. Oh, that's interesting. All right, so when we're going through the process of dimensioning, I'll try to center this a little better again. Oh wow, it really messed that up. I don't think I need to pause, but yeah, that's kind of all right, close enough. So there is that group of recommendations. If you do a search on the internet for dimensioning recommendation, do's and don'ts of dimensioning, that list will come up in many forms and fashions, and we'll be able to build in more of this. All right, so I'm going to go ahead and take this opportunity to look at the first angle and third angle projections. All right, so uh, in America, we're doing first angle. Um, so I would say, I don't know exactly what the percentage is. You may encounter first angle and third angle, and I'm not sure what I just said. America is going to do the third angle, and parts of the world are going to do first angle. And what that is amounting to is if we go into a new part and we look at how these views are generated, because they will say glass box, and that sort of works when you're starting out, but it is usually a little more um, involved than that. And one of the reasons that it's more involved in that is if we go to, and let me just make that 2 by 2. And then I'll jump into the S key real quick and get, oh, I was still in the rectangle. And I'm going to send one that way. Well, that did not pick up, so 2 and 2. All right, so if I take these two as an example, and I think I drew that the wrong way. So quadrant 1, 2, 3. Yeah, I drew it the wrong way. I actually need to reverse it that way. So let's see. No, I made those equal, or at least some part of that equal. Well, this would be a good chance to show those items. And I'm fumbling over the command manager here, so let's go ahead and do 2. The dimension's okay, but I need to reverse it. And then where is my other equal? So if I can't find the other equal, I'm going to do display delete. We're going to list all, and the other equal length goes there. Smart dimension 2. Okay, so when we're doing the Cartesian coordinate system, we are in quadrant 1, quadrant 2, quadrant 3, quadrant 4. First angle projection is in quadrant 1 coming towards us, hence the first angle. So if I extrude and we go to the sketch and I bring this cube out 2 inches, and we'll go ahead and accept. And if I share that sketch and pick this region and we go back 2 inches, now we're in quadrant 3 going away from us. All right, so let's go ahead and show all of these views. So if I'm looking at the bright plane, and this is my first angle, and it might be a good idea to set a color here for that body. And a color here for that body. Okay, so if I'm looking at the right plane and looking into the right plane, then this face is going to be my view in first angle. Hopefully I'm saying this right. Or no, I am reversing it. So if I'm looking at the right plane, in the direction of the right plane, then this is going to be facing this way, whereas if I'm looking in the direction of the right plane, that actually reverses and we're looking at it opposite. So that's why first angle is confusing to us that uh, aren't really used to working with it. Front views should be the same. Top views then, so looking in the direction of the top plane versus the top plane of the first angle. So when we look at those projections, we want to pick one and make sure that we are in the correct item. So hopefully I got all of that right. And if I go into, let's go ahead and close that now. I'm going to save it. If I go back into my drawing and I change the properties to first angle, apply changes, notice that the line, and let's go ahead and set that to hidden, shown. And that one's okay. Did that not pick up the parent? No, for some reason that did not pick up the parent style. And use the parent style. All right, so this is a hidden line because in first angle we're looking in that direction and we're looking in that direction. In third angle, then we are folding up the box to where this view is here as opposed to looking at it this way, and the top view is looking that way. All right, so minor differences. It comes back to what you're taught and what will be least confusing based on what you are taught in the way of the first angle. So in effect, a second and a fourth angle would just be repeats, and that's why we really you don't ever hear about uh, those even coming up in discussion. So that kicked me out again. Let's see if I can find that discussion real quick. Nope, that was not what I wanted. So we have the views, the orthographic projection. I do want to shrink this down a little bit. All right, so the right side views, top view, left side, height, width, depth, and the 6 standard views. All right, and the projection method, we're looking at in the line of sight. And when we fold up the glass box, then this is our first angle projection. Dang, I keep wanting to say first angle. This is our third angle projection, whereas in effect, the first angle gets folded reverse of that. And let's see, where is that one? The front view? Nope, I think I jumped over it. All right, anyway, I've confused that enough, but we will go ahead and do a little more refinement on our sheet format and our document template, and then we will start using it for the assignment.